Geographic coordinate systems are a way to uniquely identify locations on the surface of the Earth. So basically what we do is we start with the surface of the Earth or some sort of sphere or ellipsoid, and then we overlay some lines on them. Some of the lines that we overlay on them run in this orientation here, and these are called lines of latitude. So there is a central line of latitude, which is the equator. It's halfway between the North Pole and the South Pole, on which our Earth spins. So it's sort of a natural zero between the two axes of our planet. The lines of latitude then increase going towards the north, and they also increase in a negative direction going towards the south. There's another series of lines. These all cross at the North Pole and the South Pole, and these are called lines of longitude. These lines of longitude intersect each other at the North Pole and South Pole, so they're very different than lines of latitude. Lines of latitude never intersect each other, so sometimes they're called parallels, as we see here. These lines of longitude are also called meridian lines, and they represent how east or west we are on the surface of the Earth. There is no natural zero line for lines of longitude, so we just define one. It's called the prime meridian, and it runs through Greenwich, England, where there's a Royal Observatory, and everyone on Earth has just agreed that we'll call this one zero, so that when we talk about a line of 10 degrees longitude, everyone knows where that is with respect to the line of 0 degrees longitude. Finally, if we combine the longitude and latitude lines onto something that looks like this globe here, then we have something called the Graticule, or sometimes the Graticular network. That's just the lines of latitude and longitude combined. This is from your textbook, and it just basically shows the same sorts of things. Here are the parallel lines. These are the lines of latitude here, and we can see they increase from 0, 15, 30, 45, 60 until they reach 90 degrees at the North Pole. And south of the equator, we would number these with negative numbers, or say we're 15 degrees south of the equator, for example. So that goes 15, 30, 45, 60, and then we get to minus 90 degrees at the South Pole. So that point where the prime meridian crosses the equator, that would be the 0, point in the Graticular network. It's really not a special place. It's south and west of Africa, but it just happens to be where our 0, point is, where the prime meridian and the equator cross. This shows a similar pattern, once again with latitude, going from 15, 30, 45, 60, and 90 degrees as we go towards the North Pole, and minus 15, minus 30, minus 45, minus 60, and minus 90 degrees going towards the South Pole. This additionally shows how the lines of the meridian or the longitude change. Once again, the prime meridian would go through Greenwich, England, and then it gets positive as it moves towards the east. So it would go from 30, 60, 90, 120, 150, and then 180 would be on the opposite side of the world of the prime meridian. We can see that this varies from 0 to plus and minus 180, and that's different than the lines of latitude that vary between negative 90 and positive 90 degrees. You may also note that we're on the United States is on this side of the prime meridian, so our lines of longitude would actually be to the west, or they're sometimes numbered as negative numbers to indicate that's the direction that we're going around the world. And knowing those things, then we can give any point on the surface of the Earth, like such as this one here, a latitude, 52 degrees north, or just positive 52 degrees, and a longitude, 22 degrees west, or negative 22 degrees. So this lets us uniquely identify any point on the surface of the Earth with only two numbers, a number of latitude and a number of longitude.